Hello and welcome to the John Ark Show. Today we are going to interview Harvard astrophysicist Avi Loeb to discuss his theory about extraterrestrials visiting our planet and our solar system. He has a book out called Extraterrestrials: The First Sign of Intelligent Life Beyond Earth that examines the 2017 flyby of a space object that he believes was sent here by another race. Before we begin, I want to encourage you to subscribe, like, comment, and follow us. We're going to have a lot of great celebrity interviews coming up, so I encourage you to click on the notification bell so you can be notified every time we upload a new episode. I'd also like to tell you about a service called HollywoodIsCalling.com. It's a great service that allows you to purchase live phone calls from your favorite celebrities, so check them out. It's something you can buy for yourself or as a gift for someone you love. HollywoodIsCalling.com. Now, let's say hello to Professor Avi Loeb. Hello, Avi. Welcome to the John Ark Show. How are you today, sir?
I'm doing very well, thank you.
So, Avi, in your book, Extraterrestrial, you discuss the 2017 flyby of a space object that you believe was sent by another civilization. Now, to the untrained layperson, the object looks like a very long, thin rock traveling through space. Tell me what data you have that suggests that it is something other than a long rock traveling through space. Do you have any data?
Yeah, so in fact, the data was collected by my fellow astronomers when they observed this object. This was the very first object that we spotted near the Earth that came from outside the solar system. And we could tell that because it was moving too fast to be bound to the sun. And at first, astronomers thought, oh, it's just like the rocks we have seen before in the solar system. But the problem was that it didn't look like a comet. A comet usually has a cometary tail behind it of evaporated gases. When the surface of the comet gets warmed up by sunlight, the ice melts, the ice evaporates, and you create this cometary tail, and that was not visible behind this object. And in fact, the Spitzer Space Telescope looked very deeply for any gas, traces of gas around this object, and couldn't find any. Then people said, okay, well, maybe it doesn't have any ice on the surface, and it's just a rock, bare rock. But the problem with that was the object exhibited an extra push away from the sun. And usually you get such a push from the rocket effect when something evaporates from the object. And to explain the push that it exhibited, you really need 10% of the mass, of the weight of this object to get evaporated. And we didn't see any of that. So the question was, what produced this extra push? And the only thing I could think of is reflection of sunlight. And for that to be effective, the object needed to be very thin, like a sail on a boat that reflects the wind. In this case, it's the sunlight that gets reflected that gives it the extra push. I should say that from fitting the amount of sunlight that the object reflected as it was tumbling, the conclusion was, from analyzing that data, that the object is most likely pancake-shaped, not cigar-shaped, the way it was depicted or that you described. It's most likely flat rather than elongated, and it must have an extreme geometry because as it was tumbling, the brightness of the object, the amount of reflected sunlight, changed by a factor of 10. So imagine a thin piece of paper tumbling in the wind. And if you look at it, the area doesn't really change, the area that you see doesn't really change by more than a factor of 10. So it could be a very thin structure that was simply reflecting sunlight, and that's how it got pushed.
Now, you said that it appeared to be accelerating away from the sun.
Yes.
How do you know that that's not the result of being spun around the sun and then accelerated by the sun's gravitational force as it moved away?
Oh, because we know how strong that force is, and we can calculate it precisely. We know the mass of the sun, and therefore the motion of an object around the sun is predicted to an exquisite precision. And then we compare what we see for the trajectory of this object, compare it to what we expect from the sun's gravity, and we notice the deviation that implies that there is an extra force, excess push. And the question is, what provide that force? Now, in September 2020, there was another object that exhibited such a push, and there was no cometary tail. And then it was found that this object came from Earth. It's a rocket booster from a launch in 1966 of a lunar lander. And that object, the rocket booster, was thin enough for it to be pushed by sunlight again, reflecting sunlight. And we know that in that case, the object was artificially made because we made it. The question is, who made Oumuamua, this other object?
Is the push of sunlight really consequential enough to move a rock in space?
The only way you can get such a push on a rock is if it evaporates the way comets do.
Oh, I
and
see.
Then it needs to lose. So it's just like the rocket effect you get in a rocket, right. or how a jet plane gets pushed forward. You know, a jet plane throws gas back and gets a push forward. And so you could, in principle, get that if the object were to lose about 1/10 of its mass, but we didn't see anything.
So how fast does the average asteroid moving through our solar system travel as compared to the speed of this object?
Oh, the speed was only twice as large or so as compared to objects that are bound to the sun. That was not really the signature of it being strange. It only implied that it came from outside the solar system, because at very far away, it was already moving at some speed relative to the solar system.
Now, go ahead.
Yeah, and actually this object originated in the so-called local standard of rest, which is the frame of reference that you get to when you average over the motions of all the stars in the vicinity of the sun. So stars move relative to each other, and if you average over the motion, you get to the local standard of rest. It's sort of like the local public parking lot. And this object was at rest, was parked in that frame, and the relative speed to the sun is simply because the sun was moving relative to the local standard of rest. So the strange thing is only 1 in 500 stars is so much at rest relative to that frame. It's a very special initial state for that object to be in. And we just bumped into it like a ship bumping into a buoy that sits at rest on the surface of an ocean. And the question is, why was it sitting in that frame of reference? It's really unusual.
So the average layperson would assume that an object coming into our solar system that was, of natural origins would travel at a constant speed unless it was accelerated by the gravitational pull of a planet or a sun. Did this object at any time coming into the solar system or exiting the solar system change speed or direction in any way that would cause you to conclude that it was being maneuvered somehow?
No, we haven't seen that. The only thing that we noticed when it was passing close to the Earth, and I should say that to traverse the solar system, including the Oort cloud, which is the outermost part of the solar system, it would take the object more than 10,000 years. So, this is a long journey that it exhibited through but we noticed only when it came close to us, within the orbit of the Earth around the sun. And in that phase, the only thing we notice is there is an extra push acting on it that declines inversely with distance squared from the sun, which is what you expect for sunlight. The amount of light impinging on the surface of an object declines as inversely with distance squared. So the behavior of this push with distance from the sun was just what you expect for a light sail or for a thin object pushed by sunlight.
Now, at its closest, how close did this object come to the Earth?
Oh, it was not very close. It was, a fraction of the Earth-Sun separation, like of other tens of percent of that. So it never came extremely close, and I don't think it was targeting the Earth or it's a probe intended for Earth, because actually it entered the solar system as a whole, as I said, more than 10,000 years ago, when we humans were at a very primitive stage in our evolution. So there was no reason to send it to spy on us so long ago. And I think it's most likely a defunct piece of equipment if it's of artificial origin. It could be the surface layer of a spaceship that was torn apart, or it could be, just a light sail or an object that was put in the local standard of rest, as one object of a population, of a grid of objects that are placed there for a signpost for navigation through interstellar space, for example.
Now, at its closest, you're saying it still wasn't close enough to be photographed clearly. Is that true?
Yeah, it's too small. It's only a few 100 feet in size, roughly the size of a football field. And at the distance that it came, our telescopes were not powerful enough to resolve it. The way to get a photograph of it is if we were to find an object like that approaching us, we could send a spacecraft that carries a camera and takes a close-up photo. And that's what we should do for the next time around. There should be many more of the same. It's unlikely that we happen to look at the sky just when the single object that exists happen to pass by. It's very likely that there are many more out there, and either with the same telescope or with a future telescope called the Vera Rubin Observatory, we will find many more.
Now, what would it, first of all, if you could not see it with a telescope, but it entered the solar system, how did you detect it? Was it with a radio telescope? How did you detect its incoming presence?
No, it simply reflected sunlight. So the object has a certain size, the size of a football field.
Okay.
And then it reflects sunlight, and we detect that sunlight being reflected off its surface. And obviously, we cannot detect an object that is too small because it doesn't reflect enough sunlight for us to detect. And the Pan-STARRS Observatory that discovered it was surveying the sky with the purpose of finding asteroids or comets that could potentially come close to Earth. The Congress tasked NASA to find 90% of all near-Earth objects that could potentially collide with Earth, because we know, for example, that the dinosaurs died as a result of an impact of a big object, this roughly the length of Manhattan. And so we want to know if there are any dangerous rocks heading our way. And Pan-STARRS started this process of surveying the sky, and in the process of doing that, discovered this first interstellar object.
Now, is it your conclusion, based on your observations, that this is just an anomaly, or do you genuinely believe this is an alien technology or object or debris of some sort?
Well, I think it's sufficiently unusual for us to consider seriously the possibility that it is artificially made. It was artificially made. And therefore, just like walking on the beach, you very often find rocks or seashells that are naturally produced. But every now and then you stumble across a plastic bottle. And that indicates that there is a civilization out there that produced it. And we should do the same in the context of objects entering the solar system.
Now I'm going to ask you a hypothetical question that you probably may not be able to answer to anyone's satisfaction, but we're going to do it because it's an interesting question. Let's fast forward a few years from now, and another object is re-entering our solar system. What do you have to detect or see, or what do you have to detect in this object to conclusively decide that it is alien technology? Other than something ridiculous, what do you have to see?
Oh, it's very simple. You just need to come close enough to it and take a photograph, and you will see that it's not a rock.
There's
nothing simpler than that. It's a photograph is worth 1,000 words.
Okay. But of course, if it was to emit a radio signature of some sort.
Oh, that would be also interesting. But why would it transmit it in our direction? Why would it transmit it at the time that we are observing and at the frequencies that we are observing? I would argue it's very unlikely that if we were to look with a radio telescope at the object, we will see anything. A much better approach is to simply image it. Just let's take a photograph and see what it is.
Yeah, but if it was an alien ship or a vessel or something, and it entered our solar system, we could probably detect a signal from it far sooner than getting an image of it.
Well, if it transmits at the frequencies that we are monitoring and with a powerful enough beacon that we can detect it. And by the way, interstellar travel is taking a long time. You know, light takes 4 years to reach the nearest star from where we are. And so it's very likely that during a journey, a spacecraft that travels for so long would transmit only sporadically to preserve energy. It wouldn't really transmit all the time. It will transmit in very short episodes. And the chance that we are that we will be looking exactly at the time when it's transmitting, and also that it will be beaming its radiation in our direction rather than in some preferred direction, is quite small. And I wouldn't hold our hopes high that we will detect something coming from it. I think it's much better to simply photograph it.
So it's been a few years since this rock flew through our solar system. Where is it moving now? And how far can you track its exit out of our solar system before you lose all contact, all visual, all imaging?
Yeah, we already lost visual contact because it's now a million times fainter than it was when it was close to us. So it's extremely faint. We can't detect it with our telescopes. In fact, we lost the ability to detect it already a few years ago, and at the beginning of 2018. Right now, all we can do is hope to see another one, because we cannot really chase Oumuamua. It's too faint for us to trace. And if we were to, and we don't have also the rocket that will move fast enough to catch up with it. Even if we had, we needed to equip such a spacecraft with a telescope that will find Oumuamua and go there. And I think it's a much better approach to search the sky and look for others of the same.
So I've got another very subjective question for you. There are plenty of UFOs that have been photographed in our atmosphere or in low Earth orbit. Why did you decide to focus your studies on this distant object floating through our solar system rather than on one of the countless sightings of actual, what appear to be UFOs in our orbit?
Well, this object was detected by the astronomy community, the community of scientists that are using observatories for astronomical observations. And the analysis of the data from this object was done using the standard scientific method. And that I'm a scientist and I operate by the scientific methodology. Now, the UFO reports that are often made on Earth, they are not using the best scientific instruments to detect objects. And I do think
but many of them are photographs. So assuming at least some of those are true photographs.
Well, so I do think that the way to figure out the nature of these reports on unidentified flying objects is actually not to rely on reports from the past or on documents that were classified or things like that, but rather deploy the best scientific instruments at the sites where these reports came from and record the sky. You know, science is about reproducibility. You have to reproduce the results in order to believe them. So what we need to do is put the best scientific instruments in a scientific experiment that is well monitored and not based on eyewitness testimony, but based on what the instruments record. And then we will figure out whether these things are really unusual and what the cause of them might be, rather than argue forever about these reports from the past. You know, we should reproduce them in the future. Let me give you an example. In the Old Testament, you know, the Bible, there is this story about Abraham that heard the voice of God that asked him to sacrifice his only son. Okay? Now, if Abraham had a voice memo app on a cell phone, he could have pressed that app and recorded the voice of God, right? And everyone would believe the testimony. Everyone would know that God exists. So what I'm saying is, instead of relying on eyewitness testimony, we should rely on instruments that record the evidence. And then, you know, it would be just like a scientific experiment. And then let's see what we get. And I think that should be funded, such a project, because there is also the aspect of national security. Maybe some of these reports are related to instruments that are deployed by other nations that we using a technology that we are not familiar with, that are spying on us. So we want to know what these are. And just doing the experiment the way I propose, I think, will clarify the matter.
Based on the photos and videos and radar imaging that you have seen of purported UFOs, what does your gut tell you? What's the probability that...
Oh, no, it's science is not a matter of gut feeling. It's a matter of actually collecting more evidence and getting...
Yeah, but the radar imaging is pretty obvious. That's conclusive. That is science. That shot by the Navy pilots, the radar imaging.
But this instrumentation was not designed to find such objects. It was designed for other purposes. And what I'm suggesting, actually, I appeared with Joe Rogan on a podcast. And after that appearance, when we discussed the subject, there was a grassroots movement to fundraise for an experiment of the type that I'm describing to you. And my point is, let's stop discussing past eyewitness testimonies and classified documents. That is not really a productive thing for us to do, because we are talking about things that were done in the past. Let's just try and reproduce them with the best instrumentation we have now, which is much better than existed decades ago. Let's just do it in a brave and straightforward manner, like a scientific experiment, and figure out the answer. Why argue? Why discuss it? It's, just like anything in science, it's a matter of reproducing the evidence.
So on January 13th, The Sun did an article about all the CIA's declassified UFO documents that are now online at the Black Vault website. They talk about mysterious explosions and contact with aliens. Did you see the article or download any of the declassified documents that were posted on the site? And if so, what did you think about them?
Well, there are reports that sound quite unusual and interesting. But as I said, as a scientist, I want to reproduce it myself. In science, if someone tells me they did an experiment and they got some answer, that is not sufficient. I want to reproduce it. I want to do it in my own laboratory. I want to see the same evidence in order to believe it. And if indeed there are these objects and they're doing unusual things, if we go to the same sites with the best instrumentation, we should reproduce it. So this crowdfunding initiative that is now attempting to get the funding for doing such an experiment, I think is the right approach for the future. And then we can clarify. If we don't see what was reported, then I'm not sure whether to believe it.
Well, you say reproduce it, but UFOs appear and then they disappear. What are you hoping to reproduce? Some residual radiation on the Earth?
No.
What are you hoping to reproduce?
If you argue that they were a one-time phenomena, then you are arguing, just like in the case of Abraham, that the voice of God was heard only once, never after that, and therefore we should believe the story. That to me is not appealing as a scientist. I want to be able to press the voice memo up on my cell phone when God speaks, so that I can believe the testimony that the story really took place. And so the same thing with UFOs. You cannot argue that it's a one-time phenomena, never will happen again, and I am supposed to believe it. What you should argue is that this is a common occurrence. These people were at the right time, at the right place. And if other people are in the same sites and monitor those sites for long enough periods of time, they will see the same thing. Unless you argue that, then there is no way for us to believe.
That's an interesting point, because numerous UFO sightings have been photographed and videotaped by numerous people at some points in time.
So then what you are arguing is that if we do the experiment, we will find it. Good, that's exactly what I'm saying. So let's repeat the experiment and see if we...
I'm saying you don't, in such instances, you don't have to repeat the experiment, because when the UFO appeared and it was videotaped by numerous people with smartphones, but that tells you something.
Look, science is not a matter of belief. It's not you telling me a lot of people saw it, therefore you should believe it. You telling me a lot of people saw it motivates me to go out and look for it.
I'm not telling you a lot of people saw it. I'm telling you a lot of people videotaped it at the same time with their smartphone.
No, but wait a second.
Those are two different things.
Let me clarify. You are telling me a lot of people saw it. That makes the argument that this is a common occurrence, that this keeps repeating. I'm saying, great, let me take my camera, which is much higher quality.
That's not the argument. No one's presuming that it's going to be repeating over and over and over just because at one point in time a lot of people photographed it at the same time. What I'm saying is that when you have multiple camera videos all recording the same thing, that increases the believability of the event.
Well, but science is not about belief. That's what I'm trying to tell you. Science is about reproducibility. The only way you can convince a scientist that a phenomena really happens is if it can be reproduced. In other words, you can tell me that it takes once per decade. Okay, so this phenomenon occurs once in a decade. It's rare, but it does occur once per decade. So then if you tell me that, I will go to the site and monitor it for a decade. No problem. Just because people found it once per decade doesn't mean that we cannot monitor it for a decade. Put our cameras there. They would look at the sky for a decade. And if they see it, great. That proves the point. You cannot tell me that it's once per a millennium because people did not monitor that site for 1,000 years. They monitored it for 10 years, maybe 100 years. So let's put instruments for that period of time. If the phenomena doesn't repeat, it's not believable. If you want scientists to endorse the existence of these objects, you have to reproduce the evidence. And that will be the way to convince a lot of people that it's real.
No, I disagree. I don't think some things are inherently reproducible. There are unique events in time and history which are not.
But when you say unique, are you talking about once per million years? Once per billion years, once per 1,000 years.
That's undefinable because we cannot tell you what the UFO pilots are thinking.
Let me ask you if it's so rare that it's once per million years.
I'm not saying it's rare.
So if it's not rare, then I should be able to see it again.
Well, I'm saying that there are these UFO events which are photographed by multiple people at the same time, and that increases the probability of them being true. Something is being photographed by all these cameras.
It's not a matter of it's a question of how rare these events are. If they are extremely rare, the chance of us seeing it in the first place was minuscule. But if they are not very rare, we should be able to reproduce it. Well, it's a very simple logic here.
We'll have to agree to disagree. So before we wrap things up, is there anything you would like to promote?
I would like to encourage your audience to have a look at my book. And I describe in the book all the evidence that points out to this object, Oumuamua, being unusual, and all the scientific evidence we have that it's not a comet or an asteroid like we have seen before. And perhaps it was manufactured by an alien civilization, and that's worth studying by looking for other objects of the same.
Well, Avi, it's been a pleasure having you on the John Ark Show. I want to wish you continued success with your book. And if you ever do obtain conclusive evidence of alien technology, I want you to break that news on this show.
Oh, I will be delighted. You will be the first to know.
Okay. Thank you very much, and goodbye.
Good night.
I want to thank our viewers for watching and tell you that we're going to have more great celebrity interviews coming up and more breaking news stories. So we want to encourage you to subscribe to our channel and click on the notification bell so you can get notified every time we post a new episode. Thank you, and we will see you soon.